పెట్టలేదు సరే ఇప్పటికి స్టార్ట్ చేసేయండి
Hello, good afternoon students. Welcome to one more amazing session from Infinity Lane. How are you all? Sorry to delayed start here. We are in a new studio now. So welcome to NEET 1 short sessions. So we are very close to NEET examination. So we completed 1000 most expected question series and we are in one shot series. So in that one shot series, we are going to discuss about each and every topic in one single shot for 2 hours. Are you ready? So please confirm, my dear students, you all can able to see me, can hear me. Tribeni and Sumit, so many students are there waiting for us. Hi. Okay, please maintain the chart decorum and follow the class and take a pen and paper and solve the questions along with us, and also please work with us and take a noteworthy points that we are going to give. And if you have any doubts, please use the chat box and come across with any kind of doubts, it will be answered. So please maintain chart decorum and use the chat box generously for academic purpose, right? Right. Okay, it is ready. Now let us go with NEET 1 shot. Today's class is about general organic chemistry here. Good afternoon, my dear students. Vinay, hi. Sumit, actually chemistry class will be at 12 o'clock every alternate day, okay, as we are moved into a new studio, so there is a technical glitch, so we started today's class a little late. Okay, every day you just get ready by 12 o'clock, so you will be having one shot sessions. So in the general organic chemistry, we will be discussing about so many points, the entire core part of the organic chemistry, right? Yes, it will be, this session is all about the NEET 2025 aspiring students, and it will be super helpful for your NEET examination, right? It is going to be clear, right? So these sessions are going to be super important, not only to clear NEET examination, but also it will be important for you can be a topper, right? So why late? We'll start the session without any delay. So here, crack your NEET examination by simply attending our classes. So सारे chapters हो गए. Great. And please like the session, share with your friends and comment in the chat box. Okay. And subscribe to Infinity Lane NEET YouTube channel. And also in the Google App Store, you are going to have Infinity Lane app, where you are going to download the Infinity Lane app, so that you are going to get an access of live classes, mock test, create your own test at 24/7 doubt resolution sessions. And it is absolutely free. You can get use of this. Concept with questions भी आ सकते हैं ना, पक्का. And also whenever you are preparing for some examination, it is important to note how you are doing. For that, proper assessment is required, and NEET Infinity Lane, we are going to provide in proper assessment, scientifically designed assessment, NEET 2025 All India Test Series Pack. There we are going to see 27 AITS examination, उसमें 13 part test, 4 part test, 13 unit test, 10 grand test based on NEET pattern, and also 20 online NEET full syllabus mock test भी है, and 25 NEET topic wise previous year questions, and 3 physics, chemistry, biology books along with video solutions and detailed solutions and performance benchmarking with your Infinity Lane and Sri Chaitanya students. So that is going to be super awesome, and it is actually 5099 tha, and a special discount when you apply YouTube 50 off, you are going to get it for 2999, right? Okay, so in Infinity Lane we don't have any kind of benchmarking like middle class student or underprivileged students, hidden gems. So we are going to explore the importance and the intelligence of these any kind of students. So Violet, simply this is going to be free of cost from the YouTube and इसमें फायदा उठाने का कोशिश करो. Okay, Tribeni, fine, and Sumit, fine. Let's start today's general organic chemistry. It's a complete flow of organic chemistry, and in that what topics we are going to cover. Topics भी दे सकता हूँ and questions भी दे सकता हूँ, and you are going to work with that. So IUPAC nomenclature उसमें ज़्यादा discussion नहीं चलता है, लेकिन 2-3 example देना चाहता हूँ. Because in this 2-hour session, I can't take much more time of you, right? So in that IUPAC nomenclature उसमें तो छोटा मोटा important structures भी है, इसका नाम कैसे देना है, and isomerism, in that structural isomerism, stereoisomerism भी देना है, and electronic effect, in that inductive effect, resonance, mesomeric effect, hyperconjugation, electromeric effect and their effects, and acidic strength and basic strength सारे के सारे डिजाइन करना है. Get ready, एक thumbs up and fire emoji so that we can start the class. Introduction part is over, and let's start with the number 1 IUPAC nomenclature, and for that reaction intermediates with an carbocation contains something comes as a substituent or a junior functional group, and a compound root or principal root, you can say the number of carbon atoms present in the parent chain, nature of carbon to carbon bond, and as well as the functional group, senior functional groups are included in that. So if you take any structure, these are the things are important. Everybody knows this functional group and prefix and compound root word. Let us say compound contain root word meth, C1, C2 eth, C3 prop, C4 but, C5 pent, like that. Then what you include in the prefix? If any substituent is there, propyl, isopropyl, butyl kind of things comes under this. And also if junior functional groups are there, if 2 functional groups are there in a molecule, you consider one is a senior and one is a junior. So a senior functional groups comes under C suffix and a junior functional groups comes under this prefix. Okay, Queen Lucky, yeah, Tribeni Roy. So is there any lag? Can you all able to hear me and see me? Please confirm. Please confirm, is there any lag? Okay. The template will be used to give the name of any organic compound when you talk about this nature of functional groups. So the order of the seniority order of the functional groups comes under carboxylic group is the senior most, and acid derivatives is the most senior than compared to that. Yeah, थोड़ा सा lag आ रहा है ना. Okay, just a minute. Current viewer, yeah. Okay, sorry for the interruption, my dear students. Is my voice is okay? Please confirm, is my voice is okay? Is my voice is okay? Please confirm. Okay, thank you for your patience, and let us see the IUPAC nomenclature. The template of the IUPAC nomenclature system should include the root word, something should come before that, it is called prefix, that something comes after root word is a suffix. What this root word can take you? So the root word is the number of carbon atoms present in the principal carbon chain or the parent chain, and if it is C1, meth, eth, prop, but, pent, it comes like this, and the prefix comes any substituent or any junior functional group is there, that is called a prefix, and suffix talks about the nature of the functional group as well as the carbon to carbon bond. If it is an alkane, it is C single bond C, and ene C double bond, and C triple bond, it is said to be ion. And this prefix should include if any cyclo bicyclo prefix or any substituent like methyl, ethyl, propyl and isopropyl kind of things, and butyl, isobutyl, secondary butyl, like that, and also junior functional group. So when you say a group of functional groups, how do you decide it is a senior functional group or a junior functional group? That is given as acid is more compared to acid derivatives are senior, compared to aldehyde is more, compared to ketone, then alcohol, then amines comes under this. Okay, so please confirm is my voice and video is okay, is fine? Okay, that's good, it's a nice connection now. So as we moved into the new studio, kind of disturbances are coming, please bear with us, apologies for the inconvenience. Okay, talking about how do we name this compound? Okay, that how do we name this compound? So we can name this compound by taking the principal carbon chain like this, 1, 2, 3, 1, 2, 3, 4. So we have to use the lowest locant rule. When you use the lowest locant rule, the first locant is getting something over here. Okay, so 4, 5, 6, 7, it is a heptane, right? And here two methyls are there in the third carbon and an ethyl group is there in the fourth carbon. So according to alphabetical order, you have to use the ethyl while you are writing, so that we can say 4 ethyl and it is going to be 3, 3 dimethyl heptane. So this is the fundamental IUPAC nomenclature. I just wanted to give you why. So here sometimes this can be shown here, this can be shown here. Which of the following is a proper IUPAC nomenclature is a prone for very good NEET important question. And also you can say here triple bond is given here and a substituent is given. Triple bond is coming number 2 and methyl group is coming number 2. So that triple bond should be given 1 and 2, 3, 4, 5. So 4 methyl and it pent 2 ion. So like that we have to give the appropriate IUPAC nomenclature. In the NEET examination, you will be given a nomenclature in a different formats as A, B, C, D option. It is you have to decide which is an appropriate nomenclature. That's a very important point I want to know. Then give the IUPAC name of this. So let us follow. Take a pen and paper and solve it along with us so that you will understand what is the actual IUPAC number, A structure ko kaise pakadna, kaise karna. Tribeni Roy, come on. So here it is going to be a carboxylic group. साथ में देखना है. You can say it's a ketone, right? So ऐसा लगता है ये ketone जैसे है ना. This is together is a carboxylic group. Are you getting or not? And when it comes to the carboxylic group and a ketone group, who is senior? You tell me. Use the chart box generously, and it is going to be the senior. So that you have to give the number 1, 2, and 3, and 4, and 5, and 6. That is the way you have to say. And also you have, this is a carboxylic group, and 1, 2, 3, 4, 5, and this is going to be an aldehyde group. That is not a ketone. That's not a ketone, aldehyde group. And this is a carboxylic group, and you can say, and this is going to be a carboxylic group. And how to give this complicated kind of things. So let's see here. First one, so it is given as 1, the same structures. I just want to explain you here. The first one, carboxylic group, so it is called a 1, 2, 3, 4, 5, 6. It is going to be 5-oxohexanoic acid. When ketone is the junior, you have to say 5-keto or 5-oxo. Both are same. So 5-oxohexanoic acid. So in the stretch of 2 hours in our session, we are going to discuss elaborately all kinds of general organic chemistry, including isomerism, electronic effects, and acidic nature, basic nature, as well as the reactive intermediates. So stay tuned with us and work with us. Take a pen and paper, you will understand, and you are going to get very good things, and stay tuned. Okay, Tribeni Rai, any doubts? Now you are going to see this is the sixth carbon atom is having aldehyde group. Whenever aldehyde group is terminating the other side of the carbon chain, you have to use oxo, mind it. Chain terminating groups, chain non-terminating groups. So it is going to be 1, 2, 3, 4, 5, 6. So this is 6 oxohexanoic acid and this is 5 oxohexanoic acid. Clear? So you understand the recent trends in the organic chemistry nomenclature. And everybody, while preparing for NEET examination, you focus on so complicated, but you miserably do wrong things in the fundamental aspects. So be strong in the fundamental aspect. These sessions, one-shot sessions, are going to be meant for supporting the student community who are preparing for NEET 2025 from our Infinity channel, to boost up the fundamental level and basic level of subject, and you will take to the apex pinnacle part of the subject, right? So everybody, okay, those students who are in line, please confirm. Tribeni, right? Come on, next one. Here it is going to be carboxylic group 1, 2, 3, 4, 5, 6, and fourth position something is there, that is an aldehyde group. Whenever aldehyde group is not included in the carbon chain, you have to use formyl. Once you have taken the principal carbon chain, principal functional group, you have to take the other side, 1, 2, 3, 4, 5, 6 carbons. When you talk about here, 1, 2, 3, 4, 5. So this is the longest possible chain. So aldehyde group side हटा दो, इसका junior functional group मान लो and prefix में डालना. So whenever aldehyde is not included in the parent chain, you have to use formyl. Whenever aldehyde group is included in the parent chain, you have to use oxo. That is the rock solid point I just want to give you, right? Clear? And the fourth one, you can see this is the aldehyde and CH2, and this is going to be the parent chain here, right? So this is going to be 4-oxo-butanoic acid, 4-oxo-butanoic acid. But something is there on the second carbon that is written as 2-oxoethyl. That is 2-oxoethyl. Daniel Kibret. Okay, 2-oxoethyl. So second position oxo is there, and this is the ethyl part. 2 carbon side chain is called ethyl. Am I right? Clear? This is a super awesome explanation and example as well. So any doubt? Perfect. And some more examples we'll discuss, and we'll directly go into the isomerism. Stay tuned. Take a pen and paper and write along with it. Please be like a genuine NEET examination aspirant. फिलहाल आप जो किया ना, let it be. Just भूल जाओ. Last a month one shot series. If you attend the classes with us like this, and a rigorous revision can be done. So we can promise you each and every corner of the entire chemistry is going to be discussed in this series. Stay tuned and let us do. And the next one, give the IUPAC name of this. Give the IUPAC name of this. Here I just want to give you both double bond and triple bonds are there. Both double bond and triple bond is there. Okay, I just want to eliminate this. Okay, this is not there. Okay. Here what I mean to say, here double bond is there and triple bond is there, a different matter. I just want to give you some more examples related to this. C triple bond, C, double bond, C triple bond C, and C double bond C triple bond. If something is given like this, आप कैसे कर सकते हो? 3 pi bonds, ना? Okay, 2 pi bonds. Alkyne triple bond is there and a double bond is there, and a double bond is there, triple bond is there, and double bond is there. Here, when both triple bond and double bond are there, how do we give the name? Simply you can take whichever comes first. So triple bond is coming first. When double bond and triple bond is there, here double bond is coming first. Here both double bond and triple bond are there. We have to give the double bond into the consideration according to the alphabetical order. So that is the key point. So Anushka Rai, how are you? Good afternoon. In this case, what is the name of this? Hex 1-ene and 5-ine. Here hex 4-ene and 1-ine. Here hex 1-ene, 4-ine, like that. Anushka Rai, that's fine. You can write ene and right. So let's see how do we give the name of the compound. Quick. I want to know Daniel Tribeni Rai, first one, you just give it. Here chloro is there, ethyl is there, chloro is there, and methyl is there. So let us go with the lowest sum rule when all are substituents, mind it, when all are substituents. So that I just want to say it is going to be 1, 2, 3, 4, that is the lowest sum rule. So 4 chloro, 2 ethyl, 1 methyl cyclohexane. Whenever this is the functional group and this is the substituent, should be given number 1 and number 2 here. That is the reason why it is 2-methyl hexanol. Find 2-methyl hexanol. And whenever carboxylic group is there, you have to take this as a cyclohexane carboxylic acid and 2-methyl. No, Anushka Rai, this is not phenol. Whenever benzene ring is there, then only you can say it as a phenol. Are you getting or not? This is not a phenol, mind it. And you can say bromo is there and a methyl group is there. So 1, 2, 3. So you have to say 1, 2, 3, 3 bromo, 3 methyl cyclohexane carboxylic acid is the correct IUPAC name of the compound, right? Clear? Any doubt? You can say cyclohexane carboxylic acid. Whenever this carbon containing functional group is directly attached to the ring, you have to use this carboxylic acid, carbaldehyde, carbamide, carbonyl chloride kind of special suffixes has to be used. Hegenam. And one more example we'll do, directly go into the isomerism. Stay tuned. Okay, so how do we give the IUPAC name of this? Take a pen and paper, write down. Take a pen and paper, write down. And find out who is the maximum. Yes, the parent chain comes like this. It is going to be an ether. It is going to be an ether. So the name of the compound is going to be, this is an isopropoxy. And it is going to be pentan 2-1, it's a ketone functional group. Okay. And one more structure. When chlorine and bromine both are there, so you can give the name like this 1, 2, 3, 4, numbering like this. So 2 number is coming in the both ways. So you have to use the alphabetization taking into the priority, my dear students. So it is going to be 2 bromo, 3 chlorobutane. So for each and every example, I just want to take an important noteworthy points to come across with that. Clear? And isomerism, let's go into the isomerism quickly. So in this 2-hour session, I just want to take each and every point to the consideration. So stay tuned, and isomerism. Compounds having the same molecular formula but they differ in their properties are called isomers, and the phenomena is known as isomerism. This isomerism is broadly are 2 types, and structural isomerism and stereoisomerism. Let us go into the details of and conditions for each and everything, and I don't want to give more information, a dump of information. I am going to give you a crystal clear picture about this isomerism, and you are going to have a short revision for about that. And structural isomerism is further classified into chain, positional, functional, metamerism, tautomerism, and ring chain isomerism. And also stereoisomerism, you have configurational isomerism and conformational isomerism. And configurational isomerism of 2 types, geometrical isomerism and optical isomerism. In this optical isomerism, you have enantiomers and diastesteromers. We will discuss more about each and everything. So let us go into the structural isomerism. It is the overall picture about the structural isomerism. When you attend a question from NEET examination, in the middle of the NEET examination, if any question comes, you just recall this awesome table that I am going to make for you. So ये आइसोमेरिज्म क्या है, इसका कंडीशन क्या है, इसका कैरेक्टरिस्टिक क्या है. So let's talk about the chain isomerism. How they have different size of main chain or side chain. Compounds having the same molecular formula but they differ in the length of the carbon chain, either in the parent chain or in the branch. Okay, so the condition, they should have the same nature of locant, they should have the same nature of the functional group. Then only it is going to be a chain isomerism. The relation between 2 structures, you have to identify whether they are chain isomers, positional isomers, or functional isomers. Okay, Anushka Roy, come on, next. Position isomerism, and they have the same molecular formula and they differ in the position of the locant. Tribeni Roy, N-butane and isobutane are chain isomers or position isomers? They are chain isomers. They are chain isomers. Okay, and the condition, they should have the same size of the parent chain. They should have the same size of the parent chain. They should have the same nature of the PCC and side chain and the same chain nature of the locant. And the next one is a functional isomerism, compounds having the same molecular formula and they differ in the nature of the functional group. So they have the different nature of the locant. Okay, locant उसमें functional group चाहिए, a bond भी हो सकता है. Okay, it is going to have chain and the positional isomerism not considered when you talk about this functional isomerism. Okay, and when you talk about the metamerism, compounds have the different nature of the alkyl groups are called metamers. Okay, and different nature of alkyl group along with polyvalent functional group चाहिए इसको. Ether and esters are very important in this case. Okay, position iso is 1-chloropropane. Okay, and condition, they should have the same nature of functional group and the chain and the position isomerism is ignored in that. So you are going to consider this part. You are going to consider this part. Are you getting or not? And last one, tautomerism, interconversion of the functional groups which are exist in the dynamic equilibrium is called the tautomers. And I just want to give you a quick picture about this tautomerism also, because most of the students, as huge doubt about the tautomerism. I am going to explain you that, don't worry. And different position of hydrogen atoms, so that its functional group nature is changed. Only labile hydrogen, weakly bonded hydrogen is going to shifted from here to there, so that two different structures which exist in the equilibrium, that is called as tautomerism. Okay, keto-enol tautomerism is the most important form of the tautomerism, and two functional group isomers remain in the dynamic equilibrium, and that phenomena is known as tautomerism. This is about the total overall picture about isomerism. So you are not started what is ABC of isomerism. You started isomerism, you completed, but in the quick revision of the one short program, this kind of things are super awesome and important. Take a snapshot everybody. 3, 2, 1, come on everybody, snaply. 3, 2, 1, click. Okay, now tautomerism, I just want to give an extra edge of the tautomerism, right? It is also called as desmotropism. So any kind of doubt, any kind of support, it is required. You please use the chat box and please let us know, so that we can understand what you want to know, so that immediately it is going to be explained to you guys. Feel like it is a friendly class, everybody should be benefited about that. Okay, now tautomers have the same molecular formula but different structural formula due to wandering nature of active hydrogen between atoms. What is that? You can see. So CH3, you can see CH3 and C double bond O and CH3, and this is a C double bond O, carbon to oxygen, multiple bond. So it is a functional group, and this functional group is, and this is the alpha carbon. The hydrogen atom attaches to the alpha carbon is called alpha hydrogen. So what happened during the tautomerism now? Alpha hydrogen is going to be shifted from here to here, and the pi bond is shifted from here to here. So you're going to see a new structure which is exists in the dynamic equilibrium like this. So CH3 and C, ए हाइड्रोजन जोड़ने के बाद ये OH बनेगा, ये पाई बॉन्ड है बदलने के बाद डबल बॉन्ड हो जाएगा, एंड CH3 CH2 बन गया. So this is called keto form, and this is going to be enol form, and this phenomena is known as keto enol tautomerism. Tribeni Roy and Anushka. So let's focus about how this is taking place. This tautomerism is also called as cryptomerism, or otherwise called allotropism or dynamic isomerism. Okay, and also you can see various structures. Tautomers are also functional isomers and exist in the dynamic equilibrium, and equilibrium is used to show the tautomerism. Interconvertibility, right, and also by shifting hydrogen atom from the pi bond also change its position, and tautomers always exist in the dynamic equilibrium. This is a real phenomena, not like an imaginary phenomena like resonance. It happens, and also number of electrons and lone pairs in both tautomers are always remain in the same way. You can see the tautomeric structures, you can see CH3 and C double bond O and H, and it is interconverted to gives rise CH3 C double bond COH, double bond CH2. You can see the lone pairs over here, okay. It happens in the dynamic equilibrium, understand? You can check the number of pi bonds, number of sigma bonds, number of lone pairs of electrons, okay. And it is a chemical phenomenon which takes place only in the liquid state. In the solid state it do not takes place. So Nagesh Shah, we are from Infinity Learn at Central Office, Hyderabad Corporate Office. Okay, let us focus. A very important topic is going on. Okay, it never takes place in the solid state. and the process can be catalyzed either by acid or the base. Okay, it takes place in the solutions only, right? And let us talk about, you have a keto form here, and this is the enol form here. Which is more stable? You tell me, use the chart box and tell me, in the keto enol tautomerism, keto form and enol form, which is more important? C is missing. Yeah, Anush, here I made it C. Clear? Yeah. So the reason here, bond energy, keto form is more stable than enol form. This is an assertion. And could we tell you reason? What is the reason? In the NEET examination, assertion and reasoning type questions are very, very, very important. So always keto form is more stable than enol form. Therefore, equilibrium always lies in the ketone form. The reason behind this is, if anybody, yes, Tribeni Roy, your answer is correct. Bond energy of C double bond O is greater than C double bond C. Okay. So assertion is true and reason is true, and reason is the correct explanation of assertion. So the NEET examination paper is going to be given in such a way that it is not going to ask you, it is not going to take you how extent you know the subject, rather it is going to take you your understanding ability. So practice the NEET examination questions and all the concept related to the fundamental aspects, right? Yes. So assertion is true and reason is true, and reason is the correct explanation of assertion. So in our session, we are going to discuss about the concept, and we are going to discuss about the questions based on the concept and how the various formats of the questions can be given. Stay tuned. And conversion of the keto form to enol form is called as enolization. So the rate of enolization is directly proportional to stability of C double bond C. In general, I said keto form is more stable than enol form. Definitely that is in general. But there are certain exceptions where the enol form is going to be more stable as compared to the keto form. So that is due to maybe two reasons. One is, wherever aromatic nature is there, enol form is more stable. Wherever intramolecular hydrogen bonding stabilizes the enol content, it is going to be more stable. Aromaticity also, yes, definitely I am going to give you hydrogen bonding. Okay, very good. And arrange the following in correct order of enol form. Rate of enolization. Now, enolization. Now, this is a CH2 and this is called active methylene group. Okay, this is the CH2. This is the active methylene group. जहाँ पर active methylene group है वहाँ पर intramolecular hydrogen bonding जाने का संभावना है. There is going to be enolic form, and you are going to form is correct order of enolic form. You can say enolization can be seen here. You can see CH3 and C double bond O and CH double bond C, and it is going to be OH and it is going to be CH3. There you are going to get intramolecular hydrogen bonding. There you need to understand what is the correct order of that. Okay. Now here you are going to see alpha hydrogen यहाँ पर भी हो सकता है, यहाँ पर भी हो सकते हैं. Okay. Now let us see here which has a maximum stable enol content. When this hydrogen is shifted here, you can see, and this double bond is going to be shifted here, so that this is the enolic form. Similarly, it is going to form enolic form by shifting the hydrogen from here to here, by shifting the hydrogen from here to here, so that you are going to get a conjugated ene. When you talk about this hydrogen is shifted here, so you are going to get aromatic ring. So when you get an aromatic ring, na, it is going to be more stable. Are you getting or not? Clear? Aromatic ring is super stable. ಹೇಗೆ ನಾವು next, isomers, talking about stereoisomerism. Here you are going to have so many doubts. You have stereoisomerism, constitutional isomerism is also called as a structural isomerism, and it is another version is called stereoisomerism. In that stereoisomerism, you have spatial isomerism, optical isomerism. Okay, in that you have geometrical isomerism and optical isomerism and conformational isomerism, and we are going to discuss about geometrical isomerism and optical isomerism and conformational isomerism, 3 parts, and after that we are going to directly jump into the electronic effects. Okay, geometrical isomerism. So alkenes and oximes and azo compounds can show geometrical isomerism due to restricted bond rotation about. This is what is called as geometrical isomerism. So condition for geometrical isomerism, there should be a restricted bond rotation. That is the condition. And also you can see mostly the geometrical isomerism in alkenes. Okay, you can see geometrical isomerism in alkenes. You can say cis but 2-ene, a carbon to carbon double bond, 2 similar groups on the same side, you can say it is a cis. Carbon to carbon double bond, opposite side it is called as a trans. Clear? And cis trans possible only when pi bond is broken. So this interconversion is not at all possible because the carbon to carbon bond rotation is restricted. Okay, and also you can see condition for geometrical isomerism. When you want to say carbon to carbon double bond, A and B and Q and P. Okay, ketoxam and aldoxam also is there, Anushka Rai. Suresh Kumar, Abhinav, you are there again, you are coming. Okay, I miss you nowadays. Okay, lage raho, come on. A should not be equal to B and P should not be equal to Q. That is the condition for this geometrical isomerism. Okay, now oxams and aldoxam and ketoxam will come up with when we discuss about aldehydes and ketones. Okay, Triveni Rai, is that fine? If I start there here on itself, na, it takes going to be little lengthier. That's the reason why. Yes, I remember you. But you forgot my sessions or what? Are you watching the replay? Okay, it's an year journey between my students on YouTube. So YouTube, the fan club is there. Okay, and you are heading that. Okay, talking about if this geometrical isomers A and B and A is not equal to B, A and B, A is not equal to B. So this can show geometrical isomerism. And A and B and X and Y, this will show geometrical isomerism. When you talk about A and A, as these two are the same, it will not show geometrical isomerism, right? And here you can say, thank you very much, Abhinav. And you can say this and this are same, this will not show geometrical isomerism. So by looking at that structure, we can say they can show geometrical isomerism, they don't show geometrical isomerism. So I want to say which of the following can show geometrical isomerism. So that is a very, very important question in the NEET examination. So you can follow this is the condition and this is the trick you can understand to say which is showing geometrical isomerism or not. And also Which of the following show geometrical isomerism? Very, very, very important. Typical NEET based question. So I want to know what is the answer for this. So 1,1-diphenyl butene. So butene, but-1-ene. So 1,1-diphenyl. Okay. And let us write all the structures. 1,1-diphenyl but-2-ene. So this is 1,1-diphenyl but-2-ene, and should have a lot of patience. 2,3-dimethyl but-2-ene, 2,3-dimethyl but-2-ene, and also 3-phenyl but-1-ene, 3-phenyl but-1-ene. So here you can see, look at this. This is the double bond and these two are the same. That's the reason why it will not show, right? Follow? And here, मान लो यहाँ पर हाइड्रोजन है, यहाँ पर हाइड्रोजन है, right? So this is different and this is different, and this is different and this is different. This will show, and this is different, same as this will not show. And you can say hydrogens are there. This will not show. Which of the following show geometrical isomerism? I can say here second one will show. The answer for this question is 2 is the correct answer. Everybody look at that. Stay 1 minute please. Thank you very much. Thank you. Thank you. Yes. So talking about the stereoisomer, physical properties of the geometrical isomers. So based on the physical properties of the geometrical isomers can be given here. Okay, Abhinav, what do you want to type here? Anushka Roy? Okay, let's talk about the dipole moment. Let's talk about the dipole moment. Let's say comparison. Cis is greater than trans. Why so? What are the remark? Cis isomer has resultant dipoles while the trans isomer dipole moments cancelled out when the group is same. So that's what I just want to say. Here the cis isomer you can see C double bond C and clear and Cl, okay, and C double bond C and here chlorine and chlorine, and this is a cis isomer and this is a trans isomer. When the cis isomer, this is going to be, the dipole moment is like this, not equal to 0, and the trans isomer is going to cancel their dipole moment, so this is going to be 0. So like that the structure of this molecule is going to decide many things. So it can give you, so the dipole moment cis is greater than trans, that what I want to explain here. Sorry for that mistake, okay, you just focus on the class and cis isomer has a resultant dipoles as compared to the trans, and talking about the boiling point jahan par more polarization, so more polarity is there, more dipole moment is there, there it is going to have more dipole moment. So again cis is greater than trans, so the boiling point is directly proportional to intermolecular forces. You have to find out this particular boiling point. Intermolecular forces makes you the difference between which is more and which is less. Okay, and molecule having high dipole moment has a higher boiling point and will have the high intermolecular forces. So fundamentally the boiling point is directly proportional to intermolecular force, right? And also solubility in water, more polar substances are going to be more soluble, so that cis is going to be more soluble than trans, so more polar molecule has a more soluble in water, fine. And also melting point, where you are going to see the more packing in the solid substance, it is going to have more melting point. I just want to say melting point is directly proportional to packing efficiency. So the structure with more symmetrical is going to be more packed, so that I just want to say trans is going to be more than cis. So you are going to see more symmetrical isomers have the higher melting point due to better packing in crystals, and trans isomers are more symmetric than cis, so trans is going to be super packed than cis. So another last but not least, stability, it is going to, trans is going to be more stable than cis, because the trans will have the less repulsions, the molecule having more van der Waals strain, less stable, and vice versa. In cis isomers the bulky group are closer than they have the large van der Waals strain. Got it? So when you answer the questions from the NEET examination, this particular table helps you a lot. Ready? Next, let's talk about number of geometrical isomers in a polyene. More than one double bond is there. Such structures are called polyenes. So when the alkene contain many carbon to carbon double bonds, you just see, look at these formulas. When this is a R and this is another R, if the R and R1 and R2 are not equal, the number of geometrical isomers are going to be 2 to the power n, where n is going to be the number of double bonds. Last point है ना सुरेश, that's good. Stability, जिस alkene में less repulsion हो सकता है. When you talk about this alkene, let us take this. This is your cis. Let us take this. When you talk about the molecule having more van der Waals strain, what is the meaning of strain? Van der Waals strain. So the repulsion between this and this, नजदीक में है ना, ज्यादा repulsion होता है. सुरेश कुमार. And here मिथाइल ग्रुप दोनों बहुत दूर में है. सो इसमें सिस रिपल्शन ज्यादा है, इसके वजह से सिस का स्टेबिलिटी कम होगा. क्लियर? अंडरस्टैंड सुरेश? दैट्स परफेक्ट. क्लियर? वंस यू से क्लियर देन मैं आगे बढ़ना चाहता हूं. दैट्स परफेक्ट. Talking about the number of double bonds are going to be n. So if R1 is not equal to R2, so the number of double bonds is given n. So the number of geometrical isomers is going to be 2 to the power n. Now when you talk about this methyl and this ethyl, which indicates that they are not equal at all. So I have 1, 2, 3 double bonds. So as n is equal to 3 here, 1, 2 and 3. So number of geometrical isomers is going to be 2 to the power n, 2 to the power 3, 2 cube is equal to 8. है ना? So you can draw cis, trans, cis, trans, cis, 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 trans, trans. These are the combinations. I can say cis, trans, cis, 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 trans, and trans, trans, cis. 3 kinds of geometries. Okay. Anyways, let us talk about if R1 and R2, then the number of geometrical isomers are equal. So if 2 to the power n minus 1 plus 2 to the power p minus 1. So ये p क्या है? It all depends upon where p is equal to n by 2, where n is equal to even number, and p is equal to n plus 1 by 2, n is an odd number. So an example over here, this is equal to this. Now I got 1, 2, 3 odd number. So मैं ये इस्तेमाल करना चाहता हूँ. Are you getting or not? So that you are going to get total 6 number of geometrical isomers can be seen. Fine. Any doubt? Everybody use this. Use this. Take a snap. 3, 2, 1. And take the snap. 3, 2, 1. सीधा आप इस्तेमाल कर सकते हैं नीट एग्जामिनेशन में. Okay. Directly you can use this. So when the class started slowly, and a bit of internet issues, studio issues, and once the class is being started, now we are in the right way. So I think Monica should also come. P किसको represent कर रहे हैं? ना P value अलग आता है. P value is 2 types. अगर n value odd होगा तो P value ऐसे होगा, and even होगा तो P value ऐसे होगा. Okay, even का वजह से, odd का वजह से. Are you getting or not, Suresh Kumar? Suresh usually don't ask the questions. Today is asking questions. I am very happy. बहुत खुशी का बात है. समझ में आ रहा है क्या बेटा? Clear, Suresh Kumar? Right. Tripeni Roy. Actually chemistry class थोड़ा सा टाइम में अलग होंगे ना. Biology class we are going to shift it. No problem. Don't worry. Don't worry. Fine. As you are gaining knowledge in one subject, रहने दो. Tripeni Rai, do you feel this class is helping you a lot? And one time revision हो रहा है ना? Suresh Kumar, Abhinav, fine. Okay, everybody please like the session and please share with your friends. इन लोगों का भी फायदा होना चाहिए. Fine. Let us talk about 1,3-butadiene so geometrical isomers due to a resonance. How is it? Is it 1,3-butadiene? What is this? Yes, CH2 double bond CH and CH double bond CH2. Array, sir, how it is going to show geometrical isomerism? Array, it will show due to resonance. I will show you. Okay, it is going to give you the resonating structure like this. CH2 double bond CH2 and CH double bond CH2. है ना? Now once it is undergoing a resonance, you can write this structure like this or like this, doesn't matter. It is going to get CH2 and CH double bond, CH and CH2 plus a carbocation and carbanion. It is going to have the structures, and this structure can be written in two ways. This structure can be written in two ways. Look at this. CH2 plus and CH2 minus. Okay. And it is going to get CH2 plus and C double bond CH2 minus. Yes, it is going to be. So, this is a super awesome point. Everybody should note about this. त्रिवेणी, you can see when you talk about this CH2, इसके वजह से नहीं हो सकते, CH2 इसके वजह से नहीं हो सकते, लेकिन ये रेजोनेंस के हिसाब से हो सकते हैं. Assertion and reason are correct, and reason is the correct explanation of assertion. Everybody get ready with that. It is very important point. Take a note of it. Bio class today's time change is there, Tribeni, and let us go smoothly into optical isomerism. Optical isomerism. Okay, Abhinav, come on, Anushka Roy, Tribeni Roy. Right, so the compounds have the same molecular formula, same structure as well, but they are going to differ in interaction with the light. So, I want to say certain substances possess the property to rotate the plane of polarized light. Such as substances are called optically active substances, and this phenomena is known as optical activity. So, this is the light. The light has oscillations in all directions. That is called unpolarized light. When this light is passed through a polarizer, this is called polarizer. That may be a nickel prism. So, all oscillations are ceased and only one direction oscillation is permitted. That is called polarized light. So, this is called plane of polarized light. This plane of polarized light is put into a compound taken in the test tube and in the solutions. So, what happened? This light is going to interact with this compound. It is going to change its direction, like the plane is coming like this. The plane is going to change its orientation, and the observer, this is observer I, okay, he is going to observe the light in this way. So, if he observes the light in this way as it is, so the light has no deflection. If the observer observing the light little deflected, that is called rotation of the polarized light. This is called as angle of rotation. This phenomena is known as optical activity, and in this phenomena, the example of the plane of light rotate by 90 degrees, this is observed, the rotation is alpha, you can say. So, observe rotation of the plane of polarized light determined with the help of this polarimeter is produced by a solution, depends on the various factors. One is the amount of the substance in the test tube, and I want to say the concentration, molarity of the solution, and on the length of the solution examined. Here going to see, this is what is called as path length. This is what is called as a path length. Okay, and also it depends on the temperature of the experiment and also the wavelength of the light used. Okay, the wavelength of the light used. You can say the wavelength of the light used. So, I want to say in the NEET examination, it is asked about which of the following the angle of rotation, the plane of polarized light, it depends, it all depends upon these 4 points, and this what makes the compound is optically active. That is very important, my dear children. Here what makes the compound to be optically active? So the compound should have at least one asymmetric carbon. You can say carbon with 4 different groups is called as asymmetric carbon. So I want to say if A is not equal to B, is not equal to C, is not equal to D, then you can say this carbon is said to be asymmetric carbon. Are you getting or not? Tribeni Roy? Okay. Now, if you can say, if all 4 bonds on the carbon atom is satisfied 4 different carbons, and it is called chiral carbons, and if the compound is having only one carbon, asymmetric carbon, it is going to be optically active. It should have the mirror image. So optical isomerism in bromo, chloro and iodomethane. Okay, bromo, fluoro, so we can say anything. So this compound is a mirror image of this compound, and this pair of compounds are said to be pair of optically active compounds. You can say pair of mirror images and a pair of enantiomers, enantiomeric pair. So a pair of optically active compounds which looks mirror images, structurally mirror images to each other, and one is non-superimposable to each other, are called enantiomers. Enantiomers means a pair of optical isomers. तो आइए ये डेक्स्ट्रो रोटेटरी होगा, ये लेवो रोटेटरी होगा. कौन सा डेक्स्ट्रो होगा, कौन सा लेवो होगा, किसको पता चलेगा? सिर्फ यह पोलारिमीटर को पता चलेगा. So if it is rotated like this is called dextro. If it is rotated like this is called evo. Okay, by looking at the structure which is levo, which is dextro, you can't say it. Okay, but one is dextro, another one is going to be levo. So relatively you can say that. Okay, so optical isomers, and these enantiomers would have optically different, okay, and they have the same physical property, and the same chemical property. No doubt about that. Same physical property, same. We can't say because we don't have the vision to say the orientation. Only polarimeter can say. They differ in the optical interaction with the light. Fine. That's the reason why enantiomers are not separated by, they are not separated by distillation methods. Okay. So when a product is formed as an enantiomeric pair, and that enantiomers cannot be separated, so that is called racemic mixture. Okay, we are going to see that also. Optical isomerism in compounds having more than one chiral carbons. If a compound has only one chiral carbon, it is said to be optically active. If more than one chiral carbon atom is there, they may be optically active, they may not be optically active, right? So it is decided based on these 3 parameters: the plane of symmetry and center of symmetry and n-fold alternative axis of symmetry. So what is that? What is that, I will tell you. So if more than one chiral carbon atom is there, it should be noted that it should not have any element of symmetry. These are the 3 elements of symmetry. If any one of the element of symmetry is there, you can say it is optically inactive. However, it has a chiral centers. Okay, let us talk about tartaric acid. Tartaric acid. So carbon compounds having the more than one chiral carbons. So COOH, and you have CHOH and CHOH and COOH. So it is having a chiral carbon. It is going to have a chiral carbon. Carefully you see, total stereochemistry can be explained here. So let us talk about their respective optical isomers. So you are going to see COOH and OH and H and COH and H and COOH. Okay, and let us talk about this COOH. They are going to have the different orientations. This is different configuration, you can experience it. Okay, COOH and COOH, and it is going to have COOH and OH and H and H and OH. So there are three structures, I could draw that. Let's see what are the impact of that. So dear children, this is the chiral carbon, this is the chiral carbon. Okay, so you can say this structure looks mirror image to these structures. So let's say this is the structure A and this is the structure B and this is structure C. Okay, very good. Mesomer. Okay, so when you talk about this structure A, if you draw a plane over here, this structure is going to same as this part of the structure, that is called plane of symmetry. Plane of symmetry. So that what happens, due to internal compensation, this is going to be optical activity of this chiral center is cancelled by the optical activity of this chiral center. Therefore, this is optically inactive. Such compounds are said to be meso compounds. That is called meso-tartaric acid. Meso-tartaric acid is optically inactive due to internal compensation, due to plane of symmetry. What is plane of symmetry? Plane of symmetry is an imaginary plane which bisects the compound into two equal parts, and one part is the mirror image of the another part. You are going to get two equal parts, right? And while you can see this is the structure exactly looks mirror images to that, you can say this is what you can say, it is a mirror image. So when you look, that compound looks as if it is a mirror image. And these two are optically active compound. This pair is called plus tartaric acid and minus tartaric acid. And what is the relation between A and B and C? So B and C are said to be enantiomers. Enantiomers are the pair of compounds which are optically active pair of compounds which looks mirror images to each other, right? And they have the same physical properties, same chemical properties. And what is the relation between A and B and A and C? They are said to be diastereomers. They are said to be diastereomers, okay? And these diastereomers do have different physical properties and different same chemical properties and different physical properties. Okay, and this is the total picture about this enantiomers and diastereomers. And non-superimposable mirror images optically active compounds are said to be enantiomers. non-superimposable, non-mirror images are called diastereomers. The terms are very important to understand to strike the questions and select the options in the NEET examination. Okay, you are not going to ask very complicated questions based on that. Simply a question can be given, simply you are asked to find out the relation between a given compounds. That's very important. It's very important. Clear? Fine. Any doubts? You can ask us. So let us quickly calculate the number of stereoisomers. Everybody writing along with us. Okay. So calculation of number of optical isomers is very important. In this total live session, we are going to experience lot one. Okay. So let's talk when the molecule is unsymmetrical. When the molecule is unsymmetrical. So the number of optically active isomers are going to be 2 to the power n and the number of mesoforms are going to be 0. So value of A and value of M and the number of racemic mixtures R is equal to A by 2 and total number of optical active isomers is equal to A plus M is equal to 2 to the power n. I want to say here Racemic mixture means 50% molar ratio of D and L isomers is said to be racemic mixture, and racemic mixture is optically inactive due to external compensation because they have 50% number of moles, 50% of D isomer, 50% L isomer will be there. So mole fraction 0.5, 0.5. Right, it's very important. No Rashmi, you came late. Good afternoon. You came late. Okay. So total GOC we are going to discuss. If possible, isomerism tak rukenge. If we are okay, we can go ahead with this general electronic effects. Otherwise, electronic effects भी कल फिर और एक बार कर सकते हैं. Okay, it all depends on you. कैसे करना है, क्या करना है, आप सजेशन देना है, आपका डिमांड्स क्या है. It all depends on how you want. Okay, Tribedi Roy, Anushka Roy, Suresh Kumar, and Noor Rashmi, Abhinav, everybody is welcome to take the inputs. Right. Now, when the molecule is symmetrical and has even number of asymmetric carbon atoms. So, number of optically active isomers A is equal to 2 to the power n minus 1 and number of mesoforms M is equal to 2 to the power n by 2 minus 1 and number of racemic mixture R is equal to A by 2 and total number of optically active isomers A plus M. Okay. Right. So everybody written the formulas. 3, 2, 1. Click it once. So when the molecule is symmetrical and has an odd number of asymmetric carbon atoms, then you can say number of optically active isomers A is equal to 2 to the power n minus 1 minus 2 to the power n by 2 minus 1 by 2. Right? And number of mesoforms M is equal to 2 to the power n by 2 minus 1 by 2. You see how to use this. It all depends upon the total number of optical isomers is equal to A plus M is equal to 2 to the power n minus 1. Fine. Okay, now let us focus on here. Now, Conformational isomers. Whenever carbon to carbon multiple bond is there, rotation is restricted. Whenever carbon to carbon bond is free, okay, you can say the bond is free rotated. So the condition for geometrical isomer, there should be a restricted bond rotation. Whenever carbon to carbon bond is a single bond, whenever free rotation possible, there is a orientation about the relative orientation of the groups present on the each carbon atom can be seen. Triveni, right? Finish classes very soon. Definitely don't scare about that. Triveni Roy was saying, feeling very scary as we came to know 2025 NEET will be toughest. So sir, please finish classes very soon. We are going to take one shot sessions to boost the session, boost the confidence level from the students. And we are not going to give you anything which is out of NCERT. And one important thing is 2025 NEET examination will not be tough. Tough and easy is always, it is a perception. Okay, so if you feel it is easy, it is easy. If you feel it is difficult, it is difficult. I'll tell you, Tribeni, for you, I'll tell you one thing. If you know the answer for the toughest concept, you claim that question is easy. If you don't know the answer for the easiest topic, you claim that question is tough. So easy and tough is a perception. So never judge in easy and tough. अपने आप से काम करना है and take the advices from the faculties and work with a lot of confidence. सिर्फ confidence से फर्क पड़ता है easy and tough का बीच में, है ना? So focus on your confidence. Don't focus on the distractions. Okay, don't blame the distractions and stay focused. That is a very, very important thing I want to say. Okay, let the chemistry class is from book, YouTube or anywhere, but at the end you are the hero, right? Yes, agree? Triveni, agree? So थोड़ा सा छोटा मोटा आपका मोटिवेशन भी चाहिए, दे सकता हूँ मैं, right? Triveni? Now we can see it's an ethane. The ethane, the carbon atom is there. Okay, so हाइड्रोजन ये कार्बन एटम का है और एक कार्बन एटम में सिंगल बॉन्ड है. सो द हाइड्रोजन्स आर टेट्राहेड्रली अरेंज्ड. इसका हाइड्रोजन टेट्राहेड्रली अरेंज्ड इन साहर्स फॉर्मूला. सो इफ यू रोटेट दिस बॉन्ड 60 degrees now, it is going to be like this. So it gives the structure like this. So this is called Sahar's projections. In the NEET examination, rather you just show with the Sahar's projections. Let us focus on the Newman projection. A Newman projection comes like a ball here. This is called Newman projection. There are two carbon atoms. This is a carbon atom, this is a carbon atom. When it is shown that on the same axis, एक ही कार्बन एटम दिखा देंगे एंड दिस इज द कार्बन दैट इज फेसिंग टुवर्ड्स यू एंड इसके पीछे और एक कार्बन एटम है दैट इज देयर इज ए फ्रंट कार्बन एंड देयर इज ए रियर कार्बन. फ्रंट कार्बन का 3 हाइड्रोजन्स है, बैक कार्बन एटम को भी 3 हाइड्रोजन्स है. एंड इफ यू रोटेट इट इज फॉर 60 degrees here, you are going to see the structure like this, and this is called eclipsed structure, and this is called staggered structure. This is called staggered structure. Okay, so eclipse means ये दोनों के बीच एक ही एक्सिस में रहता है. Okay, and because of this on the same axis ज्यादा से ज्यादा repulsion संभावना है. Because of this, eclipse is going to be less energy and more stability. While here maximum distance can be seen, that is called staggered, and it is called energy eclipsed is greater than staggered, and stability in general, staggered is more stable than eclipsed. Okay, and I don't want to go with rotation barrier and everything, जस्ट स्टेबिलिटी का ऑर्डर इस्तेमाल करो, इसका वजह से क्वेश्चन आने का भी संभावना है. ओके त्रिवेणी, राइट. Let's talk about the conformation of butane. This conformation of butane can be written by taking into the second carbon and the third carbon. Okay, first carbon, second carbon, third carbon, fourth carbon. Let us talk about the second carbon like this. Behind that, third carbon is there. And in the second carbon, you have a methyl group over here. And second carbon has 2 hydrogen atoms here. And the third carbon has a methyl group over there, and it has 2 hydrogens behave. So this is the structure of butane. Conformations of butane काफी important topic का है, very important. ठीक है. So let us focus over here. It is going to be 2 methyl groups are in the same axis. Okay, 60 rotate कर दो. 2 methyl groups little away, and it appear like a eclipse, not fully eclipsed, and it is what is a completely staggered. That is called as fully eclipsed. Two methyl groups are on the same side, and here one hydrogen and methyl are in the eclipsed, so it is said to be eclipsed. And this is completely anti, and this is going to be Gaussian conformation. Okay, in this way, the order of stability, Anushka Rai, that's fine. 4 is greater than, 2 is greater than, 3 is greater than, Leodas, good afternoon, and 1 is the least stable. You can say the order of stability is very important. Fully eclipsed form, and 4231 is your answer. Fully eclipsed form. In this form, distance between 2 methyl groups is minimum, so the maximum repulsions can be seen. Okay, and anti-staggered, in this form the distance between 2 methyl groups is maximum, minimum repulsions, so that it is maximum stable. Based on this stability order, my dear children, you are going to expect a question from the NEET examination, direct questions from the NEET examination. Understand? Clear? And when you refer any textbook, kind of graphs will be given, is not a matter at all. Arya Thakur, you are late. Arya Thakur. Now, I want to take you one thing over here. Okay, electron displacement effects. Okay, good afternoon. So I usually see in the G preparation channels and NEET preparation channels, and here so many channels I am there. Here let us focus about the electron displacement effects, and आप जितना तक कर सकते हो उतना तक भी कर सकते हैं. आज we have inductive effect, electromeric effect, and mesomeric effect, and hyperconjugation. So in a molecule, you want to decide acidic strength, basic strength, and stability orders, whatever it may be. You have to follow maybe one or more than one effect in this. So let us focus on which effect is actually working on it. So in a molecule, maybe one effect or more than one effect can be observed. So which is the major effect that we are going to talk about? So among all, I just want to say the order of effects. So without knowing this, अब आगे बढ़ना मुश्किल है. Okay, what is that? You have hydrogen bonding is more effective whenever hydrogen bond comes now. Don't carry anything. After that, steric effect. Then aromatic effect. Then resonance comes into the picture. After resonance, you have hyperconjugation. After hyperconjugation, you have to talk about the inductive effect. So, inductive effect is the weakest effect, I would say. Inductive effect is the weakest effect, I would say. And sir, so far you can see resonance is there, mesomeric effect is nothing but resonance effect, and hyperconjugation effect is there, inductive effect is there. But in the list you can see hydrogen bonding, steric effect, aromatic effect. Hydrogen bonding, steric effect and aromatic effect, they are physical effects, not electron displacement effects. They are not formed due to electron displacement, right? They are physical effects. That's the reason why I don't want to mention here, but they are super effective than this. Okay. And one more important, sir, electromeric effect list में नहीं दिया. So why you are not given this electromeric effect in this order? Electromeric effect is a strong effect, very strong effect. Rather, I would say this electromeric effect is a temporary effect. ये effect देखेगा आपका as long as the effective attacking reagent is there. If you remove the attacking reagent or the medium, the electronic effect is reversible and it is going to be strong, and it is a reversible and a temporary effect. Okay. So when you talk about when you start the electronic displacement effect, you study extensively about the inductive effect, you understand the electronic effect, so important. But inductive effect, that you can visualize it, and it has very least priority. But the most priority should be given for this mesomeric effect and hyperconjugation as far as the electron displacement effects are concerned. Rather just say other steric factors are also there into the molecule. Right, my dear students? So, shall we start inductive effect? Anushka Rai, Tribeni Rai, Arya Thakur, Leo Das, yeah. Okay, right. Let's talk about the inductive effect. So, inductive effect is simple polarization effect. You can say when it all depends upon, inductive effect is all depends upon the difference in the electronegativity. If the compound carbon chain is there, if a group is there, okay, Cl, right, and it is having more, chlorine is more electronegative. Not only chlorine, any group or any atom which is more electronegative than this. So that ये electron खींचने का संभावना ज़्यादा होते हैं इसका. So that makes the electronegativity. You can say this is X. इसका electronegativity इससे ज़्यादा होना चाहिए. इसका वजह से इसका negative charge, इसका positive charge होता है. Right? And it is going to pull some more. It is going to be pull some more like this. This effect is induced up to 2 to 3 carbon atom. This is called as negative inductive effect. It is called as a negative inductive effect. Let's talk about the positive inductive effect. Let's talk about the positive inductive effect. So here, if any group that is less electronegative than carbon, so what happened? So electronegativity is the deciding criteria to say whether it is a positive or a negative. So that it is going to be pulled like this. इसका positive charge होगा, इसका negative charge होगा. So this is what is called as a positive inductive effect. And this carbon atom is going to have little negative charge, and it is going to have little negative charge. And moreover, important thing I just want to say, it is very, very important. The inductive effect is a electronegativity is the key point. Okay, electronegativity is the key point. In deciding inductive effect. Okay, that's very important. RH is here. Operates through sigma bond only. Sigma bond only. It operates through sigma bond only. No pi bond is involved. And it is the weakest effect. And it is the weakest effect. And it is decided by the distance than the power. It is a distance dependent. Distance dependent. Okay. So for that use DNP rule. ओके, नीट एग्जामिनेशन में ट्रिक्स देना चाहता हूं. फिलहाल आपका जो आइसोमेरिज्म IUPAC नोमेनक्लेचर तक बढ़ा. Now we are in general organic chemistry, electronic effects, where you are going to see lot number of tricks. Stay tuned. Right? So what is the DNP rule? Distance. And it is a number and a power. This is what is called as DNP rule. Whenever inductive effect comes, na DNP rule istemal karo. Okay, distance should be given much a priority. Let's talk about this here. So plus IC minus I series, whenever minus I affect, the electron is going to be withdrawn. So this is the order. How do you memorize that order? Simply look at this particular thing where the electronegativity comes into the picture. जहाँ पर electronegativity कार्बन से ऊपर है, and it is going to be a negative inductive effect, and wherever carbon से कम है, it is going to be plus I series, and it is called as plus I effect, electron releasing groups, right? And this is the order. When I just want to say negative inductive effect is directly proportional to the electronegativity difference. Okay, is directly proportional to electronegativity, you can say, right? And very important thing, and यहाँ पर और एक चीज है, any alkyl group, any functional group shows negative inductive effect, any functional group, and any alkyl group shows positive inductive effect. Fine. And only oxide ion, carbon minus, so C minus is also इसका ज़्यादा होगा, but the thing is you can see this never stays a leaving group. That's the reason why we don't study this. We start studying this, and except this carboxylate and oxide ion, all are positive inductive effect. Now positive inductive effect is directly proportional to size of alkyl group. Bus, you learn these two tricks. you're going to solve so many questions. Are you getting or not? Clear? Any doubt? Remaining? Yeah. Arya Thakur. Now, applications of inductive effect. Applications of inductive effect. Yeah. Effect of electron withdrawing group, electron releasing group on acidic and basic strength, you can say. This is very important. Everybody knows electron withdrawing group increases the acidic strength and decreases the basic strength. This is the key point. Everybody knows it. So, as electron withdrawing group effect increases, acidic nature increases, its acid dissociation constant increases, and its pKa value decreases, and vice versa. Right? And if electron releasing group effect increases, you are going to get a basic strength increases, and Kb value increases and pKb value decreases. Understand? And let us focus on compare the acidic strength. As I mentioned, alkyl group increases the positive inductive effect. Here you have positive inductive effect, and here you are going to have a positive inductive effect. Here you are going to have super positive inductive effect, and its positive inductive effect increases, acidic nature decreases. So positive inductive effect increases, acidic nature decreases, and negative inductive effect increases, acidic nature increases. Right? Now, as this is no effect, is a standard, hydrogen is going to be taken as a standard, and this alkyl group is going to push the electron, and this alkyl group is going to push the electron. It is super pushing the electron. So, we know that plus I decreases the acidic strength and greater will be the plus I, lesser will be the acidic strength, and the acidic order is going to be formic acid is greater than acetic acid, propionic acid, and isobutyric acid. Any doubt? Okay. Any doubt? That's good. Now, let's focus. One more question. Here you can see acetic acid, chloroacetic acid, and fluoroacetic acid. So, electronegativity of fluorine is greater than chlorine. Electronegativity of fluorine is greater than chlorine. That's the reason why you have fluoroacetic acid is more than, chloroacetic acid is more than, and acetic acid. So I just want to say acidic 3 greater than, 2 greater than, and 1. And Ka value, you can say 3 greater than, 2 greater than, 1. And pKa value, 3 greater than, less than, 2 less than, 1. Hope you understand it. Arya Thakur. That's fine. Triveni, Suresh Kumar, Leo Das, Anushka Rai. Thank you. And let's talk about here acidic order of the alcohols. Even alcohols you can say. Alcohols you can say they are acidic. ROH, it is going to give rise RO minus and H plus. Okay. So, if you give the electron, it is going to be unstable. If you withdraw the electron, stable. So, let's talk about This is electron is giving. Electron is super giving. Electron withdrawing. So it is going to be stable. So acidic nature is directly proportional to the stability of its conjugate base. Mind it. That's a fundamental rule. While you are going, so the order of acidic strength 3 is greater than 1 is greater than 2. Any doubt? Fundamental rule, acidic strength is directly proportional to stability of conjugate base. Right? So can we go with one more example? Can we go with one more example? Now, here this is a carboxylic group. Alkyl group has a positive inductive effect. And this is a carboxylic group. sp2 carbon has the electronegativity. So it has a negative inductive effect. Clear? And here carboxylic group, here going to have sp carbon has a negative inductive effect. Electronegativity of sp is greater than sp2 is greater than sp3, so that ये sp कार्बन का इलेक्ट्रोनेगेटिविटी sp2 से ज्यादा होगा, and it is aromatic ring should have sp2 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 छह sp2 कार्बन एटम्स मिलके ज्यादा इलेक्ट्रोनेगेटिविटी होगा. It is going to be super electronegative. Are you getting or not? So that based on minus I effect series, correct order is going to be 4 is greater than 3 is greater than 2 is greater than 1. Try to understand how the examples are being given, how you are explaining this. Got it? Collection of sp2 and sp2 and sp2 gives a super electronegativity. है क्या ना? क्लियर बेटा? और एक एग्जांपल कर देंगे. रेडी फॉर दैट? So students, if you have any doubts, use the chat box and you can discuss with us so that we can discuss any kind of doubts. And here it's a carboxylic group, and this carboxylic group 3 carbon atoms, positive inductive effect. This has minus I effect. This has minus I effect, and this has minus I effect. इसमें फर्स्ट कार्बन पर में है, उसमें सॉरी chlorine is there in the second carbon, chlorine is there on the third carbon, chlorine is there on the fourth carbon. मैं क्या बोलना चाहता हूं, inductive effect inversely proportional to distance. So more the distance and it is going to be less inductive effect. That's the reason why it is so close, it will be having more acidic strength than 3 than 4, and फर्स्ट में इंडक्टिव इफेक्ट भी नहीं है. क्लियर? Very good. So I'm expecting some questions from the students. So I know students are getting super benefit from this kind of examples. So one thumbs up and 5 emos in the class, so that हमको भी थोड़ा energy चाहिए. So I just want to make a marathon session about this, and once all shots are done, so 10 to 12 hours a single shot total organic chemistry is going to be cleared. Agree with that? Are you ready for that? Tribeni, are you there on the line? Tribeni, right? Okay. Basic nature of amines. Amines are classified as the derivatives of ammonia. In this ammonia, 3 hydrogens are there. One hydrogen अटैक एक alkyl group लगा तो primary amines होगा, और 2 hydrogens लगा के into alkyl groups लगा दिया, that is called secondary amines, and it is going to be 3 alkyl groups. It's going to be tertiary amines. In the gaseous phase, basic nature, tertiary is going to be, secondary is going to be, primary is going to be ammonia. Okay, that is a fundamental rule. But when you talk about the basic nature of amines, so we have to talk into the aqueous solution. Acidic nature and basic nature are examined in the aqueous solutions in general. That's the reason why I would take you to the NCERT level, where basic nature is directly proportional to positive inductive effect, okay, inversely proportional to negative inductive effect. That is a fundamental rule. And alkyl amines are greater basic than ammonia is greater basic than aniline. This is another fundamental rule you need to know. So if it is aqueous solution, important, it's very important to note everybody, to determine the basic strength of amines in aqueous phase. It is in the aqueous phase, mind it. We have to consider inductive effect, solvation effect, and steric effect, steric hindrance. So that what happens, the order of basic strength is therefore explained in the aqueous state, as we can't give priority and stability provided by any factor. The results of this aqueous phase is given as NCERT textbook का हिसाब से फॉलो करना. फिलहाल 4-5 बार एक क्वेश्चन ज्यादा से ज्यादा एग्जामिनेशन में पूछा गया. If this R group is methyl, secondary is more than primary is more than tertiary is more than ammonia. If the R group is not equal to methyl group, it is going to be secondary is more than, tertiary is more than, primary is greater than ammonia. So ये क्या फर्क पड़ता है primary का tertiary का? Are you getting or not? Clear? And everybody take a screenshot for this. Everybody, 3, 2, 1, click. Yeah, click here. Okay. Now, mesomeric effect. Mesomeric effect or resonance effect is the application of resonance on the provided molecules. So the first see a couple of examples which lead to the 5 definite mesomeric effect. Okay, I would say a mesomeric effect in this next class, because 2 hours is completed, and the core part of the mesomeric effect, if we start now, it take minimum 1 hour, because students actually understand total organic chemistry. When it comes to the resonance and mesomeric effect, there only students miserably fail, miserably confused there. That's the reason why I don't want my student to be confused there. So I want to take into the next session, and I'll take you to the general organic chemistry part 2 भी करना चाहता हूँ, उसमें हाइड्रोकार्बन करना चाहता हूँ. Is that fine? What do you say, Aryan? Because once we completed this mesomeric effect and resonance effect, now we have to use all effects together, and we'll talk about carbocation, carbanion, carbon free radical, and acidic nature and basic nature together. So that gives you a super clear information and vision about the organic chemistry. Otherwise, you will be in still confused state only. So, so far the concepts what I have given, it is made up of well organized examples, है ना? And it is well flown, and hope you understand these sessions in a nice way. What do you say? What do you say? Okay, thumbs up and fire emoji at the end of the session. Aryan Thakur, Leodas, Tribeni Roy. So फिर मिलेंगे कल परसों सेशंस में, and we'll discuss about the rest of the general organic chemistry topics. Then we'll start with hydrocarbons. What do you say? Okay, anyways, the time is exhausted. We'll meet with more stuff in the upcoming session. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Lane. Thank you. See you. Stay tuned. Please like the session, share with your friends, and subscribe to Infinity Lane NEET YouTube channel. Thank you very much. God bless you all.